run out, best guess, is it like 1,000 people, fatalities over 20 years?
There have been a few different estimates, and again, it depends on which dose threshold model you're using. But there have been estimates that have been I think I saw one estimate where it was only just in the low hundreds, and estimates have been as high as like 6,000, 7,000 people that will end up dying eventually from cancer that was induced from the radiation from Chernobyl. But again, it's something where we're going to have to just watch and monitor these people as much as we can until the entire population has died off, and then we can look and say how many of these people died of cancer. How is this percentage of people who got cancer larger than what it would be for a similar population given that area of the world?
I think it's extra tricky because your susceptibility to radiation-induced cancer depends very heavily on how much you've smoked. And then you want to say, well, do you attribute that to smoking or to the cancers, for example? Uranium miners, it turned out the ones who smoked in the U.S. who really got the high cancer levels. So it's a complicated thing. The UN had a number in 2006. I think it may have been just for the cancers up till today. Assuming no threshold, they got 3,000. If you put a threshold of 2 rem, then it's about 500. But the National Academy of Sciences, at this point, recommends not putting on a threshold assumption.
That's the kind of the safest assumption to make. There's no
Well, it's safe depending on...
in terms of being conservative.
It depends on,
It's a political decision.
Yeah.
I think it's political, it's not safe.
And interestingly enough, in terms of the dose models that you want to use, there's actually it's actually a theory of hormesis, where the theory is that low levels of radiation are actually beneficial. They've done some tests on like lab rats and different types of flies.
But Jeff, the reason I say it's not safe is that when you assume linear hypothesis, then you evacuate this huge area with all this stress syndromes you get.
Mm-hmm.
If you say there's a threshold of 2 rem, then you wouldn't evacuate the area. It's not obviously safe to
you're
assume
right. In
it's
terms
bad.
of making policy decisions based on those models,
Yeah.
we don't have enough information to even make a very good model. It's all essentially speculation at this point.
And then in cultivation can stir up stuff that got buried under the surface anyway.
It's true. Interestingly enough, when they were working on setting up this new safe confinement there in Ukraine, and they built this new monument within the forbidden zone for the families and workers who died in the Chernobyl accident. They wanted to, make it look nice as they bring in the TV cameras for the president of Ukraine to come in and initiate this great new monument and this new safe confinement. So they fixed up all the roads. And in the process of fixing up the roads and moving the dirt, it actually increased the radiation levels because of that. So
Is that because plants bring the radioactivity down underground?
the plants,
Why would the radioactivity not just be on the surface?
just occasional rains and stuff over time, they end up getting sifted down lower and lower. And plants actually will absorb some of the radioactive particles as nutrients in the same way that our bodies will use some of them. And so, actually, if you were going the forbidden, the exclusion zone with the detector, then you just go to the dirt. It's not that big of a deal. You scoop out, a few inches of dirt. It's much, much higher.
Wasn't there some leakage with water? To a water table, but I thought that from the containment vessel, some radiation got out through groundwater.
I'm sure that it did. I haven't read anything on it, but it would not surprise me. And if it hasn't yet, it definitely will eventually.
The breakup of the Soviet Union must have complicated problems too, because wasn't there an increase in death due to alcoholism and smoking?
Yeah, and interesting, let me skip to the end here real quick. I'll come back to it. Here's a graph of the CZ-137 levels over the years as they started monitoring them after 86. You can see an overall trend if you were to average all these together. It's going down. The Soviet government made it illegal to pick anything, like the berries and things that were growing wild in that area, to buy any food that was grown in that vicinity. It was made illegal. You had to purchase foods that were shipped into those areas. And you can see overall the rates are going down. And then you see, of course, right around here is the fall of the Soviet Union. So you have some missing data points because they weren't even taking them. And then when Ukraine finally got on its feet and became its own country, the levels were...
To put these numbers in perspective, 30 kilobecquerel Is that similar to what the potassium, natural potassium dose is in the body right now?
Well, the 30 kilobecquerels is just the disintegrations of the cesium-137, which is.
What sort of dose is that?
I'd have to sit down and look at the dose. I don't think it's.
My
not a
impression
really
is that
high
that's
dose.
about the number of decays per second of potassium-40 we have in the
Naturally
average body.
occurring in
I'd
the
have to look
body.
that up, but I think it's similar.
It probably is similar. And again, it depends. I mean, you have to calculate all that out. I haven't done the calculations. I'd have to look at it, but it's not that significant. Again, they're just monitoring here, mainly just to sort of get an idea of what this low-level dose actually will do in the long term.
Which population is this a percentage of?
These populations are from 3 particular regions. I actually pinpointed 2 of those regions on the map where we zoomed out with the 30-kilometer zone. They're just some of the more contaminated regions of Ukraine. So these are like the highest contaminations that there are in Ukraine for the population, are those ones right there.
Why would they drop like that? I don't understand that. Why you get these huge drops?
The amount of drop through here?
No, the next step over, zone 3.
Oh, this? Well, the Ukrainian government came into play and said, no, you are not allowed to eat this food anymore, and they started making sure that the shipping in of other foods came in. I mean, they were getting all of these cesium-137 levels from eating the food that they were growing in the contaminated zones.
Yeah.
That's one of the biggest things when they were talking to the new workers who were going into the to build the new safe confinement. They drill it into them over and over and over. You cannot eat the food that is grown there. Yeah, it looks fantastic. Yeah, it's way cheaper than the other food, and it probably tastes way better. But you cannot eat it because if you get too high a doses, then you're not going to be allowed to work here anymore. And actually, I talked to him, and I was asking a lot of these workers who were going in to get trained to be able to go work on the new safe confinement. I asked them, are you doing this because, are they paying you more because you're working in this, 30-kilometer zone? I said, no, you get paid the same as if you're working on building an apartment building in Kiev or anywhere else. It's just that everyone needs a job, and when you're that hard up for a job, you're going to take whatever job you can get.
Right.
Was there any increase in birth defects?
They anticipated that there would be. They found no evidence of any birth defects as a result of the accident. They were really concerned. In fact, the Soviet government was advising a lot of the women who were pregnant at that time to consider getting abortions, which would be out of the ordinary for the former Soviet Union. I mean, the amount of abortions performed there is really high. But a lot of, some women decided, no, we're just going to go ahead and keep the baby anyway, and there's no indication whatsoever of birth defects.
What about animals?
The one study I've read of animals that they've studied that are living in the most contaminated areas is actually very interesting. I can't remember his name. There's a professor at the University of South Carolina who was studying mice that were just living in the forest there in the most contaminated regions. And they'd capture the mice and bring them in, and the mice were so radioactive that they couldn't legally ship them to the U.S. And so they wanted to look at the mutation levels in their DNA. Let's see what the mutations are like in these mice. And the mice that were living in those contaminated areas had less genetic mutations than your average mouse living elsewhere in the world. And so their theory on that is perhaps an example of natural selection, and the mice who had the superior DNA repair proteins, they would be repairing DNA as it becomes damaged. The ones that had the superior ones were the only ones that were able to survive after that many generations of mice. And the other ones died out from various radiation-induced diseases and problems.
What's the difference of these two graphs?
These two graphs, these are some of the data they were able to actually find with the whole body counter.
The two different people, or what is?
Yeah, this is supposed to be like 2 different people. There's 2 different examples. You can see each of them have the cesium-137 levels and the potassium-40 levels kind of graphed out as how they're distributed through the body. Potassium-40 levels are distributed approximately the same way for every person. And they found that if the person ingested the cesium-137, that it tended to distribute itself throughout the body the same way as potassium. But when it was inhaled, it was only just localized to the lungs. And so they could actually determine the way in which the radioactivity entered the body, and then knowing that, if you know that the lungs are where all the excess dose is going, you can calculate that in when determining the whole body dose.